Hi, in this video we will learn about properties of logarithmic functions. Well, we already know the definition of log, and based on that we can figure out some facts about log. For example, the first one is that some values. What I would like to put here is that, well, if you have base b, general base b, and you're trying to find log of 1, so we are trying to see what is the number when we put in the power of b, we get 1, that is 0. And there's another value which is nice to know. Well, it is just the result of the definition, that's log of b, base b is equal to 1. Another thing that we already know, and it's worth to mention here, is the inverse function property. So the inverse function. We know that log base b is the inverse of exponential function b to the power x. It means that if I apply log base b to the power x, they will, in some ways, they cancel each other and you get x back. And also b to the power log of anything base b will be that thing. Exponential and log base b cancel each other. That's the best way to put it. But when I say cancel each other, you have to know that what I mean when you combine one with the other one, and that is what we will refer to as inverse function property. But the properties of log that are called laws of logarithmic functions. This is laws of logarithmics. So these are three important properties that we have to know. So I will continue to write in the same numbers, but these are very important. It says that, well, a log, let me put in the middle here, log of product, any base you like, is sums of logs, same base. We have a law for quotient also. So log of x over y base b is log of x base b minus log of y base b. So log changes product to sum and quotient to difference. There's also another nice and important property or law which says how log and power like each other. So here, if you have x to the power r, any exponential, any power you have, the exponent comes up front and becomes multiple of log term. So r log of x base b. Well, this is nice. Let's do some examples for these properties, specifically these last three laws of logarithmics. Let me see, I have already prepared something here. Yes, this is nice. Okay, so simplify these terms as much as you can. Here I have the first one, says log of, both logs are base 2, they're subtracting. So log of, look, the second law, Log of difference is the same base, is same thing as log of the quotient. So here would be log of 24 over 6 base 2. Well, if someone tells you what is log of 24, you need calculator, or log of 6 base 2, you need calculator. But when you subtract them, you get into the log of 4. Remember, 2 to the power 2 is 4. That means that log of 4 base 2 is going to be equal to 2. Another way of getting that number 2 is that you can see that log of 4 is 2 to the power 2, and then use the last law, so this become a multiple. And then you see that log of 2 base 2, log of b base b is always 1, so 2 times 1 is 2. So we can find that in 2 ways. How about this one? This is sum, so sums of logs is equal to log of product, so 25 times 40, and that gives us log of 1000. Again, 1000 is 10 to the power 3, so that means that log of 1000 base 10 is 3. But I like to again do the same kind of trick just to have more practice of laws. Here, this is exponent. I can bring it down as a multiple of log of 10 base 10, and that is 1. So 3 times 1 is 3. How about this one? Well, I have the sums here, then subtraction. So if you apply the laws of logarithmics, you will get 36 times 2 over 8 base 3. What would that give us? So this would give us log of 9 base 3. And either do the trick I showed you up there, or see the fact that 3 to the power 2 is 9. So the log of 9 base 3 is going to be equal to 2. How about this one? Well, 3 to the power some expression which has log 3. Remember the inverse property here? So I have b to the power log of base b of anything. They basically cancel each other. That x, the remaining will be the x. Here, however, we don't have 3 to the power just log. There are this extra term here. Well, we can take this 2 inside, but remember the law, the multiple can go in and you put it as power of whatever is in front of log. So here this will turn to log of 5 to the power negative 2 base 3. Now use the inverse function property. 3 to the power log of anything base 3 is going to be that thing. And this is 1 over 25. And this last one is 2 to the power, well, here I have 8 here, I have 2 here. These are different base. The inverse function law doesn't work here. We have to try to make into inverse function. So this is, we can write 8 as 2 to the power 3. Exponent of exponent, you multiply them. And then there's constant multiple. It goes in and becomes the power of inside. So this gives us now 2 to the power log of 2, not 3 to the power 327 base 2. 2 to the power log something base 2 will be that something. Well, you have to be able to do these kind of computations. These are the properties of log, and you have to be able to do these things. Well, there's one remark. A remark is that remember that ln is log in the base e. So since ln is basically logarithmic function base e, it has same properties. It is just log function. It's just that the notation we chose for it is a little bit different, but it will follow exactly same thing. For example, if you have log of 1 over e to the power this guy here. Oh, sorry, not log, ln. ln. Then you can write it as this one as e to the power negative 2 over 3. And then this comes up from negative 2 over 3 ln of e. Ln is log base e. Log of b base b is 1. So ln of e is 1. So this is negative 2 over 3 times 1, which is negative 2 over 3. Also, if you have something like e to the power 3 ln 2, we can do e to the power ln of 2 to the power 3. So the multiple goes inside and becomes power. Then e to the power ln. Remember, ln is log base e, and following the inverse function property, we will have basically 2 to the power 3 itself. Other than these basic properties, I actually have one more thing to add to a list of properties, and that is called the change of base formula. So this is, so far I had how many? 5 of them. This is the 6th property. 6, change of base formula. It says that, well, if you have ln of x, and if you have ln, if you know ln of b, you divide these two things, you basically have found log of x base b. What this formula says is that everything, all the logarithmic functions can be written in terms of ln. So if you know ln function, you basically know all the log function. That's enough just to divide ln of x by ln of b to get log x base b. Well, let me just do one example before we finish this, and that is example. We know that if ln of x is equal to 3 and ln of y is equal to 2, then find well, okay, so this is something that we already know how to do this one, but how about this one? Log of x base y. Okay, here, see what will happen here. This is product of two things, so we can write it as ln of the first one plus ln of the second one. Each one has exponent powers there. They will become, remember the law, this will be 2 ln x plus 4 ln y. And we know that ln x is 3, so this is 2 times 3, and the other one is 4 times 2, which you get 6 plus 8, it is 14. How about this one? Well, we only know what is ln of x and ln of y. And the change of base formula says that just divide ln of x by ln of y. You have found log of x base y. And that, in this case, is 3/2. Well, that's what we wanted to know about learn about the properties of log. The last 4 properties, the laws of logarithmics and the change of base formula, are the main formulas for us in this video.